Okay, in this video, I'm going to take you through everything in trigonometry, but specifically, I'm going to take you through all of these questions, which are the sine rule and cosine rule, and often they're mixed together with lots of other things. So some of these questions are going to be pretty tough. They're going to start off a little bit easier. So this document, if you do want to use it, it is fully hyperlinked, which means you can click through all of these things when you download it as a PDF, and it is linked in the video description. So let's get started. This one is going to be about the sine rule, and it says, here is a triangle ABC, work out the length of AB that we're looking for right here. Well, this one is going to be pretty straightforward for a sine rule. If I want to work out this length AB that I have over here, to be able to do that, I need to have the angle which is opposite it, which I clearly have at this place. Then I've got this length between B and C, but I need to know the angle that goes opposite it. So first of all, I'm going to work out what that angle is by doing 180 take away 34 and 26. So I'll do 180 take away 24 take away 36, and that angle is 120 degrees. So this 26 degrees, because it hasn't got anything that's opposite it, I'm actually not going to be using that at all, okay? So I'll just leave a kind of a line through that saying I don't need to use this. So to do the sine rule, I'm going to say that my AB, the length that I'm looking for, divided by the sine of 34, is equal to this other pair, so it's going to be this one divided by the sine of that. So that's going to be the sine, sorry, not the sine, that is going to be 23.8 divided by the sine of 120. And you know what? I'm going to make that in red so that it's the right colour that matches with what's on the diagram. Now, if I want to find out what AB is equal to, I'm simply going to multiply by sine of 34. So that's 23.8 divided by the sine of 120, and I'm going to multiply that by sine 34 and get it all typed in to the calculator. So slide my calculator back in. I'm going to get 23.8 over the sine of 120 multiplied by the sine of 34, and I get the answer to one decimal place of 15.4 centimetres. 15.4 centimetres for this one. Let's double check to see that we've got this one correct. There is the 15.4, and it was a pretty straightforward one because it was only a 3 marker. Now, this one actually says sine rule, but I will have changed this by the time you go to download this. This isn't going to be sine rule. This is actually an example of a cosine rule. And the one that we're looking for here is BC. Now, because because we are looking for BC, and we also know the length of AC, and we know the length of AB as well, then this means we can actually use the cosine rule. I'm just going to do that one so it's a straight line as well, make it look nice and neat. And we know this angle that is opposite over here, which is 72. So I'm going to say that this side, which is opposite, sometimes people like to call this like x, or sorry, like to call it x, but I'm actually going to call it just BC in this question. Now the cosine rule is this, that a squared equals b squared plus c squared, a bit like Pythagoras, minus 2bc cos of a. So the key thing is that the side you're looking for has to have an angle that is opposite. So in our case, our a squared is this length that we're looking for, bc squared. And that is going to be equal to the 8 squared plus the 11 squared minus 2 times 8 times 11 multiplied by the cos of the angle that is between them. So this B and C that we have here, the angle, which is capital A, is in between these ones that we've got. So I try not to really remember it as this formula. I try and remember it as all of this stuff is talking about two sides and the angle between, and this is the angle that is opposite. So if I want to find out what BC is equal to, I am literally just going to do the square root of what I've got there. So that's my 8 squared plus 11 squared minus 2 times 8 times 11 times the cos of 72, and that's going to tell me what BC is equal to. So square root of 8 squared plus 11 squared minus 2 times 8 times 11 times the cos of 72. It's already done the square rooting, so to 3 significant figures, it is 11.4 centimetres to 3 significant figures. Let's double check we've got this one right. Yep, there is the 11.4, so we know we have this one correct. This is now where we start doing a mixture of different kinds of things. We've got two triangles that are stuck together. We've got all the information on here. The thing that I think we're going to start off with is that the area of triangle ADC is 56. So this one that we've got here has an area of 56. So if we use the half AB sine C rule, I can see that I have got a side and I have an angle, and I'm going to try and find out what that other side is using a half AB sine C. So because I know that the area is 56, I can say that a half multiplied by 11 multiplied, I could call this x as a side, but I'm actually just going to name it what it is, multiplied by CD, multiplied by the sine of 105, that's my half AB sine C. that is equal to 56. I'm going to use this to find out what CD is. CD is literally just a length. So what I can do is I can do 56 divided by these three things that we've got here. So on the other side of the page, I'm going to put my calculator. I'm going to do 56. I am going to divide it by a half to get rid of the half. I'm also going to divide it by the 11. And I'm also going to divide it by the sine of 105, which tells me that the length of CD is 10.541, 10.541. And the reason I'm doing a few extra decimal places here is because at the end it wants it to one decimal place. So I have a bit more detail as we go. It'll probably mean I have a good level of accuracy as we go. So that is 10.541 is this length that I have just worked out here. And the thing we're trying to find out is the length of AB that we've got. Well, I think this side of the triangle is probably going to help, because once I get this side of the triangle, I've then got a separate triangle that I can do some calculations with. So this triangle that we're going to look at now, I have got my A, D, and my C. I know that this is my 10.541, this is 11, and this is 105. So I can use the cosine rule on this particular one that I've got. So I'm now going to use the cosine rule, which means that AC squared, the opposite side, is going to be my 11 squared plus my 10.541 squared, that's my A squared plus B squared, minus 2 times A times B times by the cos, because it's the cosine rule, times by the cos of 105. Now I'm going to put that all on the calculator with the square root sign, but I'll save myself a bit of writing out. So I'm going to do the square root of 11 squared plus, now that's previously stored in my calculator as the answer, so I'm actually not even going to bother typing that in. I'm actually just going to write plus the answer squared, the calculator knows what we're doing, minus 2 times 11 times the answer times by the cos of 105. So every time I've typed in answer, the calculator knows that I'm doing the 10.541. So this tells me that the length of AC is 17.0919, etc., like this. Now I know how long this part of the triangle is. It is 17.0919. So we're going to now see if we can figure out the length of AB, and that's actually going to be a straightforward sine rule because I've got these two which are a pair, and then I've got these two which are a pair. So my last part is to do the sine rule, and the sine rule is that AB divided by the sine of 148 is going to be equal to AC, which is 17.0919, divided by the sine of 118. So this thing tells me that AB is going to be equal to 17.0919 divided by the sine of 118 multiplied by the sine of 48. And I'm just going to put that all in my calculator. Remember though, this is already stored as my answer, so I can type answer divided by this times this. So there is my answer. I'm going to do the answer divided by the sine of 118, and I'm going to multiply that by the sine of 48. And we come up that A is 14.4 to one decimal place. So we get that AB is 14.4 meters. Let's see if we've got this one right. There is the 14.4, and you can see in here the process of doing the half AB sine C, and then we've got some bits here with the cosine rule and then the sine rule. They would have accepted 14.3 to 14.4. Okay, I'm going to put the calculator back to the other side where I usually keep it, and now we're going to look at this next question, which is pretty tough if I'm honest. So it's going to be a mixture of the cosine rule, exact trig values, problem solving, and it's a non-calculator one, which is why I've said exact trig values. The diagram shows a hexagon ABCDEF. ABEF and CBED are congruent parallelograms where AB is equal to BC, which is equal to X. So I'm actually just going to label that those two sides we know about are X. And it says that P is the point on AF and Q is the point on CD, such that BP and BQ equal 10. So you'll see why I switch colour now in a second, but I'm going to draw a line on between B and P and a line on between B and Q, and those are going to be 10 each. And it says given that angle ABC is 30. So I'm going to say that this whole angle that we've got at the top is 30, so I'm doing that one in blue. And it wants us to prove that the cos of PBQ is equal to this thing that we've got here. Well, this is very, very tough. I'm going to show that AC, I know something about AC and PQ. AC and PQ are the same length as each other, which means I've actually kind of got like two triangles between this, but I wonder if it's going to fill that in for me. I don't really want it to. Let me just see if I can remove that area. Perfect. So we have got two different triangles, and I'm going to draw them out separately, and then we're going to do some maths with this. So the first one is the blue triangle, and the blue triangle is with A, B, and C, where this is X, X, and 30. And then the second triangle that we've got, which is a bit longer, it looks like this, where we have P, Q, and B. This is the angle that I'm interested in at the top. This is cos of PBQ. This is the one that I'm talking about right here. And we also know that this length is 10 and this length is 10. Something else that's pretty important about this is that this length is equal to this length, because of just looking at the diagram, they must be, because they're going from one side of the parallelogram to the other side of the other parallelogram, I should say. So I'm just going to do a little side note that AC is equal to PQ. Now I'm going to do the working out of the cosine rule for this blue triangle that we've got here. So that I need enough space for this, we're going to do the cosine rule, and the cosine rule will say that AC squared is going to be equal to that side squared plus that side squared. So that looks like Pythagoras, and then you do minus 2 times these sides together, minus 2 times this, which is going to be 2x squared, times by the cos of the angle, which is 30. So AC squared is 2x squared minus 2x squared multiplied by cos of 30. This is the exact value you need to know. Cos 30 is root 3 over 2. So I'm just going to write that down, that cos 30 is root 3 over 2. And there's a bit of a clue because of that root 3 that we've got there. So my final bit of simplifying is that it is 2x squared. 2x squared multiplied by root 3 over 2. Well, those 2's that we have here and here, they're going to cancel, so that what we get left with is 2x squared minus root 3x squared. Minus root 3 x squared. Okay, now I'm going to do the cosine rule for the red triangle. So I'm going to do the cosine rule for the red triangle. It's in a very similar pattern, that PQ squared is going to be my 10 squared plus 10 squared, that's the B squared plus C squared, minus 2 times B times C. So 2 times this, that's 2 times 10 times 10, that's 200. Cos of the angle which we're talking about, which is PBQ. Remember, that's the thing we're actually trying to find here. So we get that PQ squared is equal to 100 plus 100, that's 200, minus 200 cos of PBQ. Now, I know that AC is equal to PQ, which also means that AC squared must be equal to PQ squared, because if it's the same length, it'll be the same when it gets squared. So this means I can take this thing and make them equal to each other, because that when they're squared, they are equal to each other. So my last part of working is that 2x squared minus root 3x squared must be equal to 200 minus 200 cos of PBQ. Now, I like to do a bit of factorising. I noticed that I could take a factor out of x squared here, so that I get my 2 minus root 3. And if I also take out a factor, I'm probably not going to take out the factor of this bit. What I might do is instead, I'm going to put this 200 cos of PBQ onto this side. So I get 200 cos of PBQ plus this equals 200. So my last step is to subtract this to the other side. Well, it's my penultimate step actually. So I get that 200 cos of PBQ is 200 minus x squared 2 minus root 3. All that's left is to divide everything by 200 and make sure that it looks like this. So my cos of PBQ is 200 divided by 200 is 1, and then this divided by 200 is my 2 root 3 divided by 200, and I'm just going to put the x squared at the end, just like where theirs was. And so I've shown that this is the thing that is true. A very difficult question. It's right one of the last questions in the paper, and it is worth 5 marks. So you could try and read it all through here, but I hope my version of it is going to be a little bit more helpful for you. Okay, now a slightly easier one after that very tough question. So it says here we want to work out the length of AD. So this is the thing that I'm aiming to try and find out about, and I'm going to give my answer to 3 significant figures. Well, as usual, let's just do some work on this triangle. I think actually I'm going to end up finding that one, so I might change that one to a different colour. I'm going to start off trying to find out the length of BD, because if I find out the length of BD, I've probably got enough information for that second triangle. So I'm going to concentrate on this one to begin with, okay? I'm going to look at this triangle here. Now you'll notice I have got an angle and the one that is opposite it, and I have got an angle and the one that is opposite it. So I'm going to start off by saying that BD, this is the sine rule, BD over the sine of 34 is equal to the other length, which is 12.5, over the sine of 109. So that will tell me what BD is. It's going to be 12.5, sorry, over the sine of 109 multiplied by the sine of 34. And I'm going to get that all onto my calculator straight away. So we have 12.5 divided by the sine of 109. That is going to multiply by the sine of 34, and that is 7.3926, blah, blah, blah. And I'm going to put the dot, dot, dot to show it keeps going, and I'm just going to keep it stored on my calculator there, okay? Now that I know that this length here is 7.3926, I can have a think about what's going on in this sort of red section that we've got. We're trying to find out the length of AD that we have, and I think we might be able to do the cosine rule for this, because we've now got in this triangle, I've got a side that I know about, I've got another side that I know about, and I've got the angle that goes between them, which means that I can do the cosine rule in red. So I'm now going to do the cosine rule, and remember our cosine rule is a squared equals b squared plus c squared minus 2bc cos A. And the crucial thing is that this and this are opposite each other. So this one is opposite the angle, we are good to go, which means that AD squared is equal to the other two sides squared. So that is going to be my 11.4 squared plus my 7.39 blah, blah, blah squared minus 2 times 11.4. This is going to have to move across, so I've got some more space. 2 times 11.4 times my 7.39 blah, 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 multiplied by the cos of 86. So I'm actually going to find out what AD is by typing this into my calculator with the square root sign in it, but I'm just going to save myself a little bit of time doing that. Now remember, I've already got that horrible 7-point number stored in the calculator, so I can just do the square root of 11.4 squared plus the answer squared minus 2 times the 11.4 times by the answer times by the cos of the angle, which is 86, and we get the answer to 3 significant figures, that is 13.1 centimetres. Let's double check to see that we've got this one right, please. So we do have 13.1, and you'll see in the process that we've got like the sine rule followed by the cosine rule down here. Okay, this one is weird because we're blending it together with some sort of sector of a circle. So we just want to read through and make sure we add everything into the diagram, because this one they haven't labelled a ton of stuff. The shape is made from a triangle and a sector of a circle, centre O and radius 6. Okay, so that immediately is telling me that this is 6, and between O and C, I'm just going to make that clear that it's just between O and C, that is equal to 6 as well. It then says that AD is 14 centimetres, angle AOD, so the one in the middle of those 3 letters, that is 140, and then angle OAD is 24 degrees. So this one here is 24 degrees that we've got. Now if I need to, I know I can find this one because of angles in a triangle. So I tell you what, I might do that just because I think that's the kind of thing that they like to do in these sorts of questions. So I'll do 180 minus 140 minus 24. So that one is 16. And if I use it, great. And if I don't use it, it's not an issue at all. Let's just get rid of that little bit at the bottom. Okay, so now we're actually going to see what we want to do in this question. They want us to find the perimeter of this shape. We're going to try and see what the distance is from here to here, and then between C and D, and then along the bottom. So I think what we're going to do to start off with, I think we're going to find out the perimeter just of this particular shape that we've got here. So we're going to discuss the sector of the circle, the sector arc. And the arc just means this part that we've got here. So let's highlight that so you know we're talking about the same thing. Well, I guess that the angle that we have, because that's 140, this is going to be 360 minus 140, which is 220. So the sector arc is going to be equal to the fraction of that whole circle. So that's 220 out of 360 multiplied by the circumference. Now remember, the circumference of a circle is pi multiplied by the diameter. So it's going to be pi multiplied by the diameter of the circle, which is 12, because the radius is 6. So let's find out what that sector arc is by getting that all typed in. So we're going to do 220 out of 360. We're going to multiply that by pi, and we're going to multiply that by 12. And so that we get this is 23.038 blah, blah, blah centimeters. Okay, and we're going to come back to that one later on. Now we're going to try and figure out how long this part is. Okay, now in order to do that part, I think we're going to need to find out the whole of this shape that we've got. Not the whole of this shape, but the whole of that length. We're going to try and find out the length between O and D. I might actually draw out that little triangle because I think it might help us visualize what is going on. So this is a 6, OD is the thing I'm going to look for, and this is 14. And I know all of the angles that are in here, so I'm actually going to use the ones that are opposite the sides that I know. So opposite the 6 is the 16, and opposite the 14 is the 140. Oh, actually, that's not the ones I want to use. I want to find out the length of this side here. So actually, I want to know this angle. Those are the ones I'm going to use. I actually don't even need to use these two. I can do these two. So let me correct what I've got on my diagram. We're going to use the 6 and the 16, and I know this angle is 24, and this is the one that I'm looking for. So I'm going to say, as that is the side that I'm looking for, using my sine rule, that OD divided by the sine of 24 is going to be equal to another pair. Now I could do the 14 and the 140, or I could do the 6 over sine 16. It's going to literally give us the exact same answer. So if I do 6 over sine 16, this will tell me that OD is 6 over sine 16 multiplied by sine 24. Let's see what this gives us. So that is going to be 6 over sine 16 multiplied by the sine of 24, and we get that OD is equal to 8.8537 blah blah blah, like this. So the perimeter of the shape is going to be equal to the yellow part that we've got, which is my 23.038. Then I'm going to add on the 14 that I've got along the bottom, and then I'm going to add on, well, this part that we've got here is 8.8537, and I only want this CD length. This CD length is going to be this one minus 6. So it is going to be my 8.8537 minus 6. And if I put that all together, it should give us the perimeter. So sliding the calculator back over to this side. Remember, I've got that 8.857 stored as the calculator. So I'm going to type in 23.038 plus 14 plus the one that's on the calculator, that 8.8537 minus the 6. Oh, didn't mean to do that bit. So if I just press minus 6, it should work. Now I'm worried I've done something funny when I typed it. No, I haven't. I have done that all correctly on my calculator. I just pressed equals twice. And we get that the perimeter is 39.9 centimeters, which I can just see on the next page is the right answer that we have here. Okay, we have now got a bearings kind of question, but it is basically just a trig one. If it's question 23, it's likely to be sine and cosine rule. It's so late in the exam paper. So it says that Barston is 8 kilometres from Acton on a bearing of 37. Chorlton is 9 kilometres from Barston on a bearing of 150. Find the bearing of Chorlton from Acton. So I'm going to start off by just joining these two lines together, and I'm going to try and find out what that whole bearing there is. In other words, I kind of need to find out what this angle is, because then I can put them together to find that out. And it wants us to give up to 1 decimal place. Well, look what I've got. I have got the side, and I have got the side, and I think what I'm going to need to do, if I'm going to try and find out what this angle is, I think what I could try and do is find out this side, then I will find out something to do with an angle. Sorry, let me say this again. I'm going to try and find out this angle, which will allow me to find out this side, and then I think I've got enough to do the sine rule with all of this stuff that we've got going on. Now, this is why this question is really difficult, in my opinion. I think I can find out what this angle is using the properties of bearings. First of all, if this is a vertical line and this is 150, then this is 30. Similarly, if these are parallel, which they are because they're the north line, if that's 37, that must be 37 because they are alternate angles, which sometimes people call Z angles, but they are alternate angles, which means that is 37. So if I redraw this triangle that I've got, and it's going to be a very sketchy version of it, I have my A, my C, this angle at the top is 67, this is 8 and this is 9, so I'm going to figure out what the length AC is. Now AC is going to, AC squared using the cosine rule is 8 squared plus 9 squared minus 2 times 8 times 9 times the cos of 67. So I can figure out what AC is by typing that in, but obviously with the square root sign that's going to go above it as well. So I'm going to do the square root of my 8 squared plus 9 squared, always starts off a bit like Pythagoras, minus 2 times 8 times 9 times the cos of 67. And we get that AC is 9.4199. I'll tell you what, when I use it in my calculations, it's actually so close to 9.42. I'm just going to use it as 9.42 kilometers. So if I now go back to here, this is 9.42 kilometers. Remember, this is the angle I'm trying to find out. So I actually think I've got enough information to do this. And you know, if it's a 5-mark question, you're probably going to be doing the sine rule and the cosine rule once each, maybe some other bits as well. So I know that this is 67. This is the angle I'm trying to find out. That one has opposite a 9. And the one that I have opposite here is my 9.42. So if I call this angle x for a second, I'm going to say that the sine of x over 9 is equal to the sine of 67 over my 9.42. So this means that sine x is going to be sine 67 over 9.42 multiplied by 9. And then I'm going to find out what x is by doing the inverse sine of that in just a second. But let's get some of that on my calculator. So typing this in, we get that the sine of 67 over 9.42 multiplied by 9 is this answer that we get. So let me just write down what x is equal to. Actually, I'm not going to do that. I'm going to write down that we're going to do the inverse sine of that. So x is going to be the inverse sine of what we've just worked out to find out what the angle is, and that is, where's that all gone on my calculator, 0.8794. Now, I'm just going to keep it stored in my calculator, which is why I don't need to worry about writing down all of the numbers. So I'm going to do the inverse sine of the answer that my calculator had, and that is going to give me that x is 61.6 degrees, and that's to 1 decimal place. Therefore, my final step is to say what the bearing is equal to. So the bearing is going to be 61.6, and it was okay to round it there, plus that 37. And so my final answer for this is 61.6 plus 37. I probably don't need a calculator, but I'm going to do my 61.6 plus 37, and I get that it is 98.6 degrees. But because it wants it as a bearing, we should actually put at the beginning a 0, so it is 098.6 degrees. Let's double check that we've got this one. There is the 0.986. And we've got the correct part. Now, they actually would accept it like this. I don't think, it says condone a missing 0 at the front. So if you didn't have that missing 0 at the front, that would be perfectly okay in this question. Okay, we are nearly there. I think we've got 2 questions left. Well done for sticking with it so far. So all of this information is basically on the diagram, apart from this part. It says the size of angle DAC is 2/5 of the size of angle BCA. So I'm going to go and call this one 5x. And then if I'm going to say I want 2/5 of that, well, a fifth of that is x, which is why I picked 5x. And if you times that by 2, you get 2x. And it wants us to calculate the length of DC that we've got here. We're going to try and calculate that length. Well, I think we've probably got some information with this large triangle, and we know that one of the sides is 5x. So if I look at the large one, this is going to be the way I'm going to find out what the size of x is. So I have a 5x, a 6.1, a 3.4, and a 6.2, and I'm going to do the cosine rule. So the cosine rule, some people remember this rearranged, but I actually just don't. So I'm going to say that it's this one squared equals this one squared plus this one squared minus 2 times this times this times the cos of this. So pretty intense. So it is 3.4 squared equals 6.1 squared plus 6.2 squared minus 2 times 6.1 times 6.2 multiplied by, let's see if I can just slide this over so I've got a bit more space, multiplied by the cos of 5x. Now, some people know how this rearranges. If you want to do this as a rearranging, you can do this, minus this, divided by this whole thing. So that is going to be my 3.4 squared minus 6.1 squared minus 6.2 squared, all divided by minus 2, because there'll still be a negative 2 at the beginning. It's going to be minus 2 times 6.1 times 6.2. That is the cos of 5x. So I'm going to use that to find out what 5x is equal to by saying that 5x is therefore going to be the inverse cos of that whole thing, 3.4 squared minus 6.1 squared minus 6.2 squared, all over minus 2 times 6.1 times 6.2. Okay, that will then tell me what x is, and then we can keep going on this pretty insane question, to be honest. Oh yeah, of course, the calculator's on the other side. So I'm going to do the inverse cos of, get this as a fraction, we're going to do our 3.4 squared minus 6.1 squared minus 6.2 squared, all over negative 2 multiplied by 6.1 multiplied by 6.2. And that is telling me what 5x is equal to. So 5x is 32.08 degrees. So I can find out what x is equal to by dividing it by 5. And if I divide that by 5, I get that x is 6.416 degrees. So I'm going to need some more space. I'm going to need to come over to this part of the page. So I now want to find out what the length of DC is. Well, I think I might need to find out what these angles are. So this is 2x. I'm going to say that 2x is double that one that I've got on my calculator. So let's multiply that by 2. That is 12.83. So this is 12.83. The 5x I can find out as well. I think I've actually got the 5x. It was down here as 32.08. And then I can find out what this other angle at the top is as well by doing 180 minus that. So that is going to be 180 minus the 12.83 minus 32.08. So the one at the top is 135.09. And now I'm going to find out what the length of DC is. So DC divided by the sine of this, which is the sine of 12.83, is equal to, I can say this length, because I know this one, divided by the sine of that. So that is going to be 6.2 divided by the sine of 135.09. And I'm actually just going to put this all in my calculator to save us a bit of time. I'm going to do the division, and then I'll multiply it by the sine of 12.83. So that is 6.2 over the sine of 135.09 multiplied by the sine of 12.83. And we get that DC is, to three significant figures, 1.95 centimetres. So I'm just going to quickly say on here from my working, it then kind of comes up to that place. Let's see if we've got this one right. There is the 1.95. What a relief. Because I kind of do these questions a bit on the fly, so it's very good for me to see when I've got them right. Okay, last one in this section, and it is tough. It's the last question of its 23, I should think. We have ABC as a triangle. D is the point on BC such that the angle BAD and angle DAC are both equal to x. Prove that we've got these kind of things here. This looks a bit like it's come from some kind of ratio. Now what I'm going to do, this is probably not the way that people might see this. This is just the way that I would see this one. I'm going to try and compare the area of these triangles in two different ways. One of the ways I'm going to do it is the very simple way of just saying I've got the height of the triangles. So both of them have got a height of h. You can see that they both have a height of h. And when I say a height, I mean it's like the perpendicular distance. So I can say that the area of this triangle number 1, and then I'll do triangle number 2. So for triangle number 1, I could say that the area let's just do this. The area of triangle 1 is a half multiplied by the base multiplied by the height. The area of triangle 2 is a half multiplied by the base multiplied by the height. But I could also work out the area of triangle 1 in a different way. I could use my half AB sine C, which would be a half multiplied by AB multiplied by AD multiplied by the sine of the angle between them. And for triangle 2, I could do the same thing. I could say that it's a half multiplied by this side and this side, so that is going to be my AD multiplied by AC multiplied by the sine of the angle between them. Now I should know something about these things. I should be able to say that the area of one triangle divided by the other should be the same as this one divided by this one. Kind of doesn't matter which way round that I do it. If I'm going to do triangle 1 divided by triangle 2 in blue, that should be equivalent to doing triangle 1 divided by triangle 2 in red, because we're talking about the same triangles that we've got here. In other words, this one as a proportion of this one is the same as this one as a proportion of this one. So I'm going to write that down. I'm going to say that my half BD multiplied by H divided by my half DC multiplied by H must be equal to, and this part's in red, my half AB times AD sine X divided by my half AD multiplied by AC multiplied by sine X. Now the good thing about this is the half here and here will cancel, the height here and here will cancel, the half here and here will cancel, the sine X will cancel, and the AD will cancel, which leaves us with BD over DC equals AB over AC, which is actually very close to what we've got here. The only trouble is we want the AC to be in the numerator and the DC to be in the denominator, and we want the BD to be in the denominator and the AB to be in the numerator. So what we need to do for this is we just need to say that I'm going to multiply up by the AC, so we get BD times AC all over DC is equal to AB. Hang on a second, yeah, that's good. And then I'm going to divide by BD, so I get AC over DC is equal to AB over BD, which is the same thing we've got here, but just written the other way around. So this was a really hard question. I can't see many people having got this one right at all. Like, to begin like that is kind of crazy. So I think we can probably just see that we've got this is right. Yeah, so we've arrived at the given answer. I mean, it's my comparison with these kind of things. I guess we could say here with a bit of an explanation, the ratio of areas are the same with either method. Okay, this was a mega long video. What I'm going to do in the next video is just a couple of questions about graphs of trig functions. But hopefully you'll notice sine rule and cosine rule, very popular topic, always near the end of the exam paper and always a lot of marks.